Hello, everybody. You're welcome to our conversation today. Before I introduce myself, let's talk about the very first slide, which is asking a very direct question if your AI agent is the attacker. So what I mean by that is that your model that you connect to your agent might not suddenly becomes evil. What I mean is if an attacker can manipulate that agent, the agent becomes the thing that helps the attacker carry out their objective, like reaching your tools, your transaction, your authority, and the likes. And that is the frame for today. So quickly, for context, my name is Stephen Ajayi. I lead the offensive security team at Hacken. And most of my work is about looking at system the way an attacker will look at them before an attacker even gets there. So my background is offensive security, Web 2.5 security, red teaming, penetration testing. And now I do a lot of AI system and agent penetration testing and red teaming. So on this slide, you see a couple of my offensive security background, books, and certification. So if you are into AI red teaming and you want to read some good material, I would suggest you check them out. So we are going to look at AI agent from an attacker side, then translate that into architectural decision for builders. And I don't want this talk to feel like another AI hype talk. That's not what we're doing today. The point we're going to be touching is going to be very practical because, as we know, software is moving from system that can answer questions to system that can understand, that can reason, right? System that can take action, especially now that the MCP protocol is there and there are a lot of agentic framework that makes those connections easier to build. And what that does is it changes how we think about security because if a normal assistant gets something wrong, it might like give you like wrong answer or leaks data or give you like a bad summary and all that, which might lead to like lawsuits if it's critical information. But when it comes to Web3, if a DeFi connected agent gets something wrong, it usually costs money, right? So whenever I'm reviewing one of those systems, I am not only asking myself if the model can be tricked, I am also asking what authority actually sits behind the model when it gets tricked. And that is where the conversation is changing today, because prompt injection is becoming more than a text problem when language can move through tools and becomes execution. So today, we're going to be following that part together. We're going to be talking about when language enters the system, how the model reason over it, how the agent like reaches for tool, when the tool prepares for an action, and somewhere down the stream, how that could lead to loss of money. So as we go through this session, please keep one very important question in mind. Where should the system stop trusting language and start enforcing policy, right? And that is the thread for the whole talk today. But before we jump into the nitty-gritty, let's go through the agenda for today. So we're going to start the conversation by talking about collision, where AI security and web security actually collide. Then we'll look at the actual changes that happen when an AI system can influence financial execution, right? After that, we talk about the kill chain, talking about the threat modeling, the five-step DeFi agent kill chain, how untrusted language can get into context, how we can change the agentic reasoning, and how that reasoning could turn into a transaction risk. Then we're going to look at the defense architecture, sorry, the attack pattern first. We talk about the two very important AI security issues, which is the direct and indirect injection. After that, we talk about the defense architecture, where we talk about the tool boundaries, the different other defense mechanisms that could be implemented, like output validation, transaction policy, the human in the loop, simulation, monitoring, and alerting, and the likes. Then we'll talk about real-world cases. We're going to talk about Drift real-world case today. So, and at the end of the session, we'll also talk about the how to verify difference, the gap analysis, and the takeaways. So by the end, you should have like a way to reason about how agentic system can actually influence financial system. Uh, where does the language enter? Where does the authority begin? What's it in between them? And the like. So let us start with the first thing in our agenda, which is the collision. So AI security and AI and Web3 are two different worlds, and right now they are starting to overlap. So the slide has incident numbers and OWASP category on it. So I do not want us to read it like a spreadsheet. That's not what we're doing. Just use the number as context. The deeper point we need to talk about in here is the trust model. Because AI security usually talk about reasoning being manipulated, things like prompt injection, tool misuse, memory poisoning, data leakage, unsafe output, and others, right? While Web3 security often talk about authority being approved, talk about smart contracts, wallets, signers, bridges, governance, the RPC infrastructure, the backend API, the cloud infrastructure behind them, the CI/CD key management, and also the human factor, then social engineering. So Web3 security is not about the smart contract bug. The smart contract matters. So does everything around the contract that can influence what gets signed, what gets upgraded, what get routed, and what get deployed or approved, right? So the question here is simple. What the system trust? So in AI system, the trusting is often language, right? We know the prompt, text, it can also be retrieved document, it can be a memory entry, it can be a tool response, a summary from another agent. And in Web3 system, the trusting is often authority, right? And the authority is usually a signer, a role, it might be a multi-signature threshold. It can be a governance action, a transaction payload. It can even be an off-chain service with privileged access, right? So agentic system connect those through trust model, right? Because they can now read language, they can now reason over it, and they may even influence authority. That is where the collision begins. Now, what AI is doing in the mix is changing the decision-making strategy, right? And why Web3 is changing the consequence, right? If something happened. And as we know, blockchain only responsible for validating structure, right? What blockchain does is it checks your signature, the permission call data, and the protocol rules. Blockchain does not check the intent of what your transaction should be. It does not know whether the decision you're making is coming from a clean instruction or a poison document or even a manipulated UI or a confused agent. So for the rest of the talk, this is the line that we actually care about, which is, can untrusted influence reach authority, right? So let's make that a little bit abstract by comparing AI outputs with financial output. So this is where the collision actually becomes real, right? As we know, a normal assistant like ChatGPT, every other agent you use on a daily to daily basis produce content, right? They can even take actions, right? Not necessarily connected to transaction, but a DeFi connected agent can produce an influence action that has to do with transaction. And the one difference that changes the threat model is the transaction. Because if a normal assistant fail, what you usually get is a bad answer, you get a bad summary, or a data leak if an organization is connecting LLM to their enterprise workspace. But if a DeFi AI agent fails, you might get a bad approval, a wrong swap, right? A dangerous bridge route, and it usually leads to loss of money. And here's the part where I want us to slow down on, because a valid transaction in DeFi is not automatically a safe transaction, as we know, right? As I've said earlier on, the blockchain can verify if the signature is valid, right? It can verify that the caller has permission. It can verify every other thing like the call data, if it matches the function, but it cannot verify whether the user understood the action that they are carrying out, right? It cannot verify whether the context has been poisoning. This is why model output needs to be treated like a proposal and not authority. For example, when the AI agent or the model connected, it says, I think this action should happen, right? Something outside the model should be asking every other question. Question like, is this action allowed to happen? And that is a very critical design move, right? You do not want to make the model the final decision maker when it comes to financial execution, right? Let the model do the reasoning, but have a policy that enforce every other execution. Now, that is the principle we're going to be talking about today. And before we talk about the defense, let's talk about the kill chain for a minute. So far, the idea is the model is going to output the proposal and not the authority. Now, if you turn that into a sequence, right, what has to happen for language to become financial execution, right? It is not one magic prompt. In real system, it is actually a chain. The very first thing that happens is what everybody knows already, which is the prompt injection. Untrusted language enter into the system context. So that could be from direct injection, like a user prompt. It could be indirect from token metadata. It could be governance text, event log, API responses. It could be from retrieve document, or even from another agent that the DeFi agent is in communication with. So the second thing that can happen is the hijack. The model is going to give the language the wrong role, is going to treat it like instruction, and that is where the system or the trust failure is. Then the third thing that happens is abuse, when the agent is able to reach for the tool. So maybe at that instance, it's calling the wrong tool. Maybe it calls the right tool with the unsafe parameter. Maybe the tool should even not be available for the task in the first place. Then the fourth thing is when you when it tries to like build a transaction, right? And the risk here is going to be transaction shape. Now, we are not talking about the text or the prompt anymore. We're talking about addresses, amount, signers, approval, route, deadline, and all that stuff. So the 15 is the inject, where the transaction reaches the signer or the broadcast part. That is how the language becomes a financial execution. So it's not just prompt injection and that's it. So when you review a system like this, you need to think through the part like an attacker. Where can I place the language the agent will read? Which tools can I make the agent use? Which validation layer can I bypass? What signer or approval flow sits between the end, right? That is the attacker conversation. The defender version goes beyond that with additional question like, what or where does the chain break if the model or the AI agent gets it wrong? And the very first place you want to expect is at the beginning of the chain, right? And also another question is where can the attacker place the language? And in Web3, we have a lot of them, right? So which leads us to the next slide. Because when I say injection point, the chat window or the chat interface is not only the injection point when it comes to Web3, right? And I think that's one of the mistakes teams usually make. They test the prompt box and leave every other thing. But in Web3, the prompt box is just one thing, right? Your agent may also read like token names, token symbols. They might read metadata, government proposal, there's the event log, there's the transaction memos, the bridge messages. The lists keep racking up. There's a lot of data that could influence the model behavior. And most of them usually looks very harmless. It looks like just normal data. But to the language model, it's still language, right? Because the language can be interpreted. And that is actually where the risks start. So I want us to imagine a token description that was meant to be metadata. And if that description contains instruction and the agent is able to read it into context, the system has to decide what those instructions are, right? The first question is going to ask the service, are they data or are they authority? So if the architecture does not preserve that boundary, the model may treat those public data like private instruction. And we've seen it happen a lot of time, right? And this is why indirect prompt injection actually matters as much in Web3 space, right? The attacker may never even talk to the agent. They may just publish content where the agent is likely to read later. So the design habit is going to be simple. External content is also data, right? Not authority. So you need to be able to like tag it. You need to be able to separate it. You need to validate it. And you need to make sure that the source is visible. Do not at any point let the public language quietly becomes instruction, because once you see the environment this way, the two main attack pattern is going to be very easy to follow, right? And the very first one is the obvious one. Everybody knows about them, right? Every team speak about them, which is the direct prompt injection. So this one is the one that a lot of people usually think of first, which is the attack that puts the attacker in the conversation, because they are trying to interact with the agent. They're trying to change what the agent thinks. They're trying to like confuse the agent, right? So it can come in different formats. They can even try to social engineer the agent, or to put it better, prompt engineer the agent or the model to do something malicious. So the move is the interesting part. The attacker is not just trying to make the wrong action look like the correct action, right? That means that they are attacking the agent decision frame, right? Trying to understand what the agent listens to, the type of rules it follows, the goal the agent is actually optimized for, and which tool it thinks belong to which task. So this is why whenever I'm carrying out red teaming and someone say our system prompt says the agent cannot do this and all that, right? Good. Your system prompt is good. Keep the system prompt, but the system prompt should not be gospel, right? We should not confuse guidance with enforcement. The system prompt is not access control. It is not wallet permissioning. It is not transaction policy, right? So whenever I'm reviewing an agent, I usually ask myself this question: what happens if the model says something is forbidden? Can the tool still be called, right? Can the parameters still pass that specific validation? Can the spender be unknown? Can the transaction reach signing? Right? That is like the practical review. So you're not only testing whether the prompt resists the attack, you're testing whether the architecture is going to survive the model being wrong. So direct prompt injection give us the first rule. Do not put the conversation directly upstream from financial authority, because if we stop there, we are going to miss a lot of Web3 native attack, because there are some instances whereby the attacker may not even need to speak to the agent. They may only need to control something the agent read, right? Which brings us to indirect prompt injection, which is usually quieter. And in Web3, it is often more an interesting pattern, right? Because at this point, the attacker does not even get to message the agent at all. What they need to do is just poison something that the agent might read later. So it might be token metadata, it might be documents, it might be something upstream, something that is on the blockchain, right? It might be symbols, description, and stuff like that. So if the model or the agent is able to read that specific instruction, and the instruction somehow get into the context from there, it is going to influence a decision. And the danger is that the input might look very basic. It might look very ordinary. But once an agent can reason over them, they are no longer just display text. They become cognitive input. And cognitive input can actually become operational influence, right? That is the shift we need to notice, because the attacker is not always attacking your agent directly. Sometimes they just find a way to attack the world around the agent, right? Where the agent read from. So that same pattern can show up in multiple places. So it can show up in proposal, posts, documents, descriptions, agent-to-agent communication, and so on and so forth. So whenever you're designing or you're auditing an agent, you need to be able to ask yourself several questions. Question like, what came from the user? And what came from the system? What came from untrusted service or trusted service? And what is coming from public environment? So if those boundaries somehow collapse, your data can become instruction. And once that happens, your prompt is not enough to make the system safe. The answer is going to become architectural. So you need to find a way to control the model, not only the prompt inside the model, right? So, which is why we are talking about the defense in depth, right? Because the last point I made actually move us from the attack into the architecture. Now, if context is part of the attack surface, then the answer cannot be better prompt, right? The design has to assume that the model see hostile input and still keep the system safe. That is the mindset shift that we need to have, because prompt hardening can actually help, right? But it does not fully save you from prompt injection. Input filtering helps as well. Context separation usually help. Detection classification also help. Use them religiously. But in a financial system that has to do with money, do not make your final boundary just input filtering or sanitization and prompt system hardening. For DeFi agent or a Web3 agent, the stronger control should live outside the model, right? You want to be able to control that. So you want least privileged tools, you want strict output schemas, you want parameter validation, you want transaction allow list, you want approval caps, you want to have spending limits, you want to make sure that the agent knows the contract age that it is interacting with, right? You want simulation, you want policy gateway. You also need to add risk-tied human approval. Human in the loop is very important. Also, monitoring and alerting is also very important. Now, what this help you is with is you make sure that the model is just recommending and not carrying out the final action. The policy you have in your backend or in your infrastructure is the one that is going to that is going to decide rather, right? And that is the core principle in here. So this is not a new security ideas. We already know that untrusted input should not directly control privileged actions or operations, right? Now, agentic system just make that mistake very easy to hide. So whenever you build your enforcement layer, you need to make sure that it is looking at a lot of facts right? Whenever the DeFi agent is interacting, you need to know what contract is interacting with. The function is actually calling, the amount is the transaction is, who the spender is, what route is it taking, what is the source of the request, what is the risk level, and those are the type of deterministic action you want your system to validate, right? Because the saying that the model is going to behave because of prompt is not a security boundary. It's either you have a security policy that is going to block an unknown spender or it does not. So is either you have like an approval cap that is going to reject unlimited approval or it does not. All this layer matters. One layer is not enough when it comes to critical decision in Web3, right? Because at the end, the risk is usually loss of fund. And this actually brings us to the transaction policy gateway. So think of the policy gateway as the boundary between reasoning and authority. So whereby the agent is going to propose an action, the gateway is going to decide whether the action can move towards signing or not. That placement is very important because if you add it too late, after the agent already has broad access to tool and lose execution part, it becomes very hard to enforce cleanly. So this is a design decision you need to make early because the gateway should not hear that the model sound really confident, right? Because the model sound very confident. There are times that you will chat with an agent and it is going to confidently give you a wrong answer, right? And that's what we call hallucination. So you need to make sure that you're not just caring about that the explanation is fluent. Your system should be able to inspect the action itself, right? In the sense that it is reviewing the destination, right? It is checking the kind of value that the agent is trying to approve or the agent is trying to run, right? It should also check if the transaction or the approval is an unlimited approval, right? If the spender is known, if the contract is a new contract, which is usually the pattern when it comes to Web3, it should also check if the bridge route is actually an approved one, if the action is actually a normal action for your wallet, right? And you should also have an ideology that not all action should go through, right? Some actually require human approval. So these check are a lot of check. They are not glamorous, and that is why they work. That is totally fine because security often depends on layers and layers of security that works every time. So that would make sure that you're not having an unknown spender, you don't have unlimited approval without escalation, no admin operation without simulation and delay and the likes, because the model may be tricky, but if you have transaction policy gateway, the transaction will still be blocked. So that's the difference between reasoning failure and a financial loss. So this is also where valid and safe actually separate. Because the chain can tell you whether the transaction is valid or not. The gateway is going to decide whether the transaction should be acceptable or not. All right. But this does not remove the human in the loop, right? It tells the system when the human review is actually very important, right? And that leads us to the next slide, which is the human in the loop, restart human confirmation. So at this point, we've spoken about the policy checks, the limit, the allow list, the simulation, but some of those actions still need human judgment. Now, the question we need to ask ourselves as engineers or developers or people in Web3 is how do we make that judgment useful? Right? Because human approval is not automatically a strong control if you're not implementing it correctly. You can implement a button that everybody is going to click without reading it, right? Because they think it's just adding friction to the whole flow. Now, the approval has to be tiered. It has to match the risk you're trying to secure against. For example, for low risk action, like read-only queries, balance check, price lookup, portfolio summaries, and the likes. Do not add friction there. Those two should actually stay very smooth. Let it approve, auto approve, one click, no problem, right? For the medium risk action like small swap, carrying out transaction to known destination, routine transaction that is below a particular threshold, had a lightweight confirmation, and that should be enough. Now, for high risk action, you need to slow the flow down. So stuff like large transaction, bridge transaction, governance action, treasury movement, admin operations, there should be a reviewer process before confirmation. The same thing as the same thing as the critical actions, right? You need to bring in stronger control when it comes in India. So hardware wallet confirmation needs to be added. You need to have multi-signature, you need to have delay, you need to add out of band verification or manual review. The goal is not to make everything painful, right? Because if every action looks urgent, users are going to stop reading it, right? We know there are a couple of times whereby we register into a platform and we don't even go through their rules and regulation and their whatever the readme they have in that platform that you're trying to sign up on, right? So because usually they have like long list of documents you don't want to go through, and that is usually friction, right? And we don't want to do that. So the goal is to make sure that dangerous action are understandable before they become permanent. So whenever you are designing an approval screen, you need to make it answer different questions like what is this action doing and why is the system asking for it? So what could go wrong? What kind of context caused the agent to actually propose it? And this question actually matters because user is not only approving a transaction, they are approving the output of the reasoning process. So you need to make sure that the intent is visible enough when it comes to high and critical actions. And that actually brings us to real world lessons, and which is all about what happens when people sign valid action without clearly understanding the intent, right? So talking about the drift protocol. Now, to make this clear, the drift attack is not an AI attack, right? It's not, there was no LLM involved, no chat box was prompt injected or jailbroken in any way, right? And I personally think that this is why it's actually very useful, because it shows us a principle that applies beyond AI. If attacker compromise the decision layer and they're able to validate execution, right, and that execution produce unsafe outcome. According to chain analysis blog posts about, I think it was around this month, Drift actually lost $285 million after an attacker gained privileged control through social engineering. So not just social engineering, they also did something called the durable nonce transaction, and they were able to gather valid signature from Security Council member. Now, this slide is calling out the long separation window and the short execution window because the ratio matter, because they had to prepare for 6 good months. So they were building trust for 6 months and the attack only took few seconds. So that is exactly the kind of control plane race we care about when we're talking about automation, or when automation actually entered the picture, because the key lesson here is stable, because even if the incident detail involve valid signature, do not mean that the intent is safe, right? The contract can behave the same way as it's designed to. The signature can be valid, your governance threshold can be met, the transaction can execute normally, and the result can still lead to loss of funds. Now, bring that back into AI connected DeFi. The agent might not even hold the key, right? It might not be the signer, but it can influence the decision layer. So it can influence what gets recommended, what gets memorized, what gets routed, what gets labeled safe, and what the signer actually thinks they are approving. So with human signer, attacker use social engineering. With AI workflow, attacker may use prompt injection, poison context, manipulated tool output, compromised front end, or misleading transaction summaries. AI just make the capability grow larger and larger because they are different methods, but the same control plane risk applies. So the lesson here is not that drift of prompt injection, as I said earlier on. The lesson is do not let clear intent become signed authority, right? That is why you need to simulate before signing. You need to make sure that payload are understandable. You need to slow down privilege action, right? Whenever your agent is interacting with unknown contracts, you need to escalate it. You need to be able to block unknown approval, right? You also need to limit what one workflow can approve. So this is where Web3 operational security and AI security actually meet. And when discipline meets, the language is very important because usually the AI team, the protocol team, the backend team, all the different team you have in your organization might be speaking different language. And after drift, the need for those teams to have a shared language is very important. So for the table in the slide, is not there for us to memorize anything that is there. So it is there because we want to make sure that different teams can recognize the same risk when they are working on a project that laps between what each other does. Now, what I mean is when an AI engineer is talking about prompt injection, right, a Web3 engineer should hear untrusted instruction flow, right? When someone say excessive agency, all those engineers should think, okay, too much authority behind the agent. When we talk about insecure tool use, the Web3 engineer or the protocol engineer should understand that it could lead to unsafe action construction, right? So that matters because these systems are not owned by one team, right? The AI team owns maybe the system prompt and the reasoning. You might have the backend team that owns the tools and the backend APIs. Then the protocol team might owns the contract and all other invariants. The product team are responsible for the front end, the UI, UX. The infrastructure team might own the key, the cloud, storage, or the cloud infrastructure, the CI/CD pipeline, and the deployment part. Now, the security team needs to see the whole picture, right? Because attacker is not just looking at one gap between one of the teams, right? Attacker are looking for gaps between each and every one of those teams, right? They are looking for places where one team assume another team is meant to be enforcing the boundaries or putting in security measures in place. So whenever you're reviewing an architecture, you need to keep asking yourself one question, right? Where can an untrusted influence become trusted action? So as a person or as a Web3 engineer, if you can answer that question, you already know where the strong controls belong. Right now, we can then turn that into security decisions. Right. So if I had to turn this whole session into the first 5 security decisions for team, I would actually start here. Right. And in the slide, it says 5 things to implement this sprint, but I would like us to treat those items as long-term decision habits that you should inculcate into your flow, right? So these are things you can start this sprint, and it should also remain in the system after the sprint ends. So the very first thing is you need to separate recommendation from execution, separate the brain from the hand. Let the model be responsible for proposing, have a transaction policy gateway that is going to decide, right? The model output should not flow directly to a signer. So secondly, you need to be able to treat all external data as untrusted, right? That includes the user prompt, the token metadata, the governance text, the API output, the front-end data, everything that the agent have access to. Anything that comes from outside the trust boundary should be kept visible. Do not let it blend into the system instruction. The third thing is least privilege on every tool. You need to reduce tool permission. For example, if an agent only needs a tool that helps them fetch prices, there is no reason why you should give them tools that can carry out swap authority, right? Carry out transactions, right? If it only needs to draft, there's no need to give it broadcast or write permission. So the tool set usually define the blast radius, and you want to keep it as strict as possible. So the fourth thing here is human gate for irreversible action. So you need to enforce human in the loop, and not just that, you also think about the transaction policy gateway for irreversible action, right? Critical action should always be approved by human, right? You also need to have a transaction gateway that is going to be checking the destination, the value, the function, the asset, the spender, and every other information before the signing happen. So, and that should be between the human gate and the deterministic rules you have in the backend, not just the model reasoning, right? So the fifth thing is log the full part. So you want to log the prompts, the context, the reasoning, the tool call, the parameter, the simulation result, the approval decisions, the final transaction, because when something happens, logs make it easier for you to carry out forensic investigation so that you know what happened and you're not just guessing. So that is what we should actually be looking at implementing. And the long-term principle is simple. Untrusted language should not walk directly into trusted execution, right? Because your model is going to change, right? The framework you're using is going to change. The attack payload might even change, but that principle should always remain the same. So let me close this by bringing it back to the first idea I mentioned earlier on. You need to always assume the agent will eventually see hostile input, right? And that is why you need to be able to design the system in such a way that that input cannot move straight into execution. So that is the arc of the session. That's what I have in my portfolio to give you today. The main idea is we need to understand is that language becomes reasoning, and the reasoning can reach out to tools, and the tools can approach authority. And if the action is unsafe, the policy, the transaction policy gateway you have should stop it before it becomes execution, right? Thank you, everybody. I appreciate the time. The slide also has some resource link as well for people interested in learning about AI security or the Web3 security. It has linked to the OWASP, Gen AI methodology, and the Matrix AI, and also for smart contracts. And if agentic system that is connected to DeFi is something your team is actually building, which include intelligence system, AI agents, wallet assistant, DeFi automation layer, or anything where AI can influence user decision or financial actions, please scan the QR code on the slide and reach out to Hacken. We are happy to have like a security conversation with you early, right? So that might mean threat modeling. It might mean us like looking at your architecture, reviewing your agent to permission, looking at the transaction policy you have in place, right? And the best time to have that conversation is now when you're building, right? I mean, we can also have that conversation if you have already built your AI agent. Then we need to look at what you have built and what kind of security mechanism you have in place, if that should change or not. So security should always be part of the conversation you're having, and it should not be an afterthought when something goes wrong, right? So that is the conversation I wanted to have with you today. You can also reach out to me directly. I'm on X as 5M477. And before I close the session, one thing I would like you to take back to your own team is do not start by asking, is our prompt good enough, right? Start by asking what happened when the prompt is not good enough. Because at some point, that agent is going to see hostile input, especially when it comes to Web3. And that is not pessimism, it is engineering. If the agent reads any public information, those public information will become malicious. And if that agent has tools, assume that somebody out there is going to try to manipulate those tools. And if your agent can influence in transaction, you know what's going to happen in Web3. Attacker will always try to study that part from beginning to end, and they will try to influence it. So the design you need to have in mind is you need to add transaction policy, you need to input validation, sanitization, prompt hardening, right? Transaction monitoring, you need to threat model early. You also need to make sure that you are separating the reasoning from execution. You are limiting least privilege in terms of tools, because the more tools you give your agent define your blast radius, right? And you also need to simulate transaction before anyone signs them, right? You need to log everything. You need to put the policy between recommendation and signing, because once an AI system are connected to money, in Web3, we already know that attacker will always treat them like financial infrastructure. So we have to secure them like financial infrastructure. So thank you everybody for joining and listening to my short talk. I am happy to go to take any question. I'll just look through the chat if anybody has any questions. So the very first question I have here is, what are the emergent agent framework or tools that allow agentic transaction and agent handling wallet? Can you suggest any framework to implement this? So there are no specific transaction, I mean, not that I know of, framework that allow for agentic transaction. You need to create those yourself, or you need to reach out to security professionals. Then based on your architecture and what you have in your pipeline, you can then come up with work together to implement or come up with one that fits into your framework or that fits into what you're building. So there is no one specific rule that is going, or framework that is going to help you fix this. You need to come up with a specific framework that could help. So the second question is, wondering if there is well-known security policy language, or does everyone just write it in text and keep it in their head? So as I've said, there is no one security policy language right now when it comes to agentic system, right? It has to be custom made, because everybody has different workflow and different implementation when it comes to adding AI to their workflow, right? So you need to work with security agencies that understand how AI works and how to actually protect against them, and then come up with a policy. So another question is tampered evident log. I wonder if there is a technology that will be good for reproducing those. I mean, there are a lot of organizations that are now introducing AI infrastructure into blockchain, into layer one itself. So I know of a couple of organizations that are doing that. So I think that is something that can actually work, so that every action the AI agent is actually carrying out is actually stored on chain. It can be verified on chain, and you know where the source is from. I mean, you not know, because when it comes to blockchain, it is pseudo anonymous. So yeah, you usually need to, yeah, it's actually very tricky. But yeah, there are organizations coming up with technology like that. Do we have any other question? Letting your agent run his own wallet is terrifying if at some point it takes an objective of being careful with his money. Absolutely. I mean, across Web3 management, in more general terms, what a transaction limit that call for senior approval. I mean, that depends on you. All right, you know what you have to like set the cap for your own transaction limit, and it also depends on the kind of transaction, right? So for, as I've said earlier on, for high risk transaction or large transaction, you definitely want to put some sort of mechanism in there, right? You need humans to be carrying out, to be pressing the last button and not make the agent actually carry out the whole flow, right? From the reasoning to the execution, you need to put some sort of security control before the execution itself. Do we have any more question? Okay, I think that's it. In the absence of no more question, I hope this session is insightful. So if you want to speak about your product that you're building, if it's AI connected, please do not hesitate to scan the QR code and reach out to us at Hacking. We are doing some really important things when it comes to AI security and also building our own framework that could help. So it's actually a custom framework. So it is not specific to one type of infrastructure. You know, in Web3, we have like different infrastructure. So reach out to us. We're happy to jump on the call with you. We're not just your typical security firm. We act like your security advisors. We advise you on what you need to do, how you need to go about it. And at the end, you will see value when it comes to talking to us about the products you're building. So thank you, everyone, and have a good day. Cheers.